Hello, hello, hello. Mrs. Shapiro here with our next little video about how to factor using greatest common factor. So here we go. What we're looking at is what's factor, and factor is something that's multiplied, like 3 times 4, they're factors of 12. What factors are common to both 8 and 4? So you might notice 4 is a factor of both of these. So this would be 4 times 2. This would be 4 times 1. So we're going to take out this common factor and put it in front. And what's left is 2x to the 5th minus, and all that's left here is a 1. Okay, so that's how we factor for a common factor. Let's look at this next one, 25 and 10. Do you notice a factor that of both of those numbers, 25 and 10? And you might have noticed that 5 is a common factor. So 25 is 5 times 5, 10 is 5 times 2. They don't have any variables in common, so we're just going to look for a common factor of 5. We write that out in front. What factor is left is a 5, a plus, a 2x squared. Okay? Next one. These both have an 8 in common, but they both also have a negative. So let's say we have a -1 in common, and then an 8, a -1 and an 8. So we're going to say that they have a -8 in common. All right. Here's another way of looking at this. -8 times 1 equals -8, and -8 times a positive a squared equals -8a squared, right? Negative times positive is negative, negative times positive is negative. Okay. On number 7 here, we don't have any integers in common. The only factor that's common for a -4 and a 3 is 1, and that's just not helpful. So we're not going to use 1 as a common factor. But these both have an x to the first power. So if they share a variable, if they both have a variable in common, the common one is whatever's the lowest. So x to the first is common, and x times -4x to the 5th equals -4x to the 6th, and x times a positive 3 equals 3x. You might notice here these both have a factor of 4 in common. They have a 2 in common, but we want to take the greatest common factor, the biggest factor they have in common. So that's a 4. They both also have a negative, so let's call it a -4 in common. And so he would have -4 times 4 here and -4 times 3 here. When we take out that common factor, we're left with a 4b to the 4th and a 3, and there's no variables there. Okay. Sometimes they might have both integers and variables in common. So let's look at these both separately. What's the biggest number we know that is a factor of 32 and 20? Like, what's the biggest number that divides into both of them? And I believe it's a 4. This would be 4 times 8, and this would be 4 times 5. And they have variables in common, so we're going to have to look at that. So we'll take out that common factor of 4 first, and then let's look at the variables. This one has n to the 4th, this has n to the 3rd. As I said, when the variable's common to both, the lowest power is what's in common. So n to the 3rd is what's in common. Here's maybe a different way to look at this also. 4 times what is 32? 8. N to the 3rd times what would be n to the 4th? That's an n. 4 times 5 would be 20. N to the 3rd times nothing else would be n to the 3rd. Okay. Let's look at this next one. There's a 90k, a 90k to the third, and a 9k. So it's pretty obvious that they have a factor of 9 in common. And then they both have a k, so the lowest power is first, so that will be the common variable, k to the first power. Okay, we took out a common factor of 9, so there's a 10 left here. We have one of the k's out in front, so there's still 2 left in there. And then all that's left in common here is a 1. And that's right, 9k times 1 would be our 9k. Okay, I think you've got the idea there. Let me show you a few other problems. Maybe a few bigger ones. So when we get into these big trinomials, let's look at number 19 here. Okay, kind of obvious that they've got some power of 10. They all have a 10 in common. Okay, so we're going to say 10 times 2, 10 times 7, 10 times 2. They all have an m, but it's just m to the first that's in common. So 10, m to the first. We took the 10 out. There's a 2 left. We have one of the m's here. So we took 1 out of here. So that's m to the 7th. All right. Next one, we take out the factor of 10 is already out in front. So we have a 7 here. We have an m here. We need an m squared to have m to the third. We took out the 10. So we have a 2. There's an m here. We already have it accounted for here. So we're done. To check this anytime, 10m times 2m to the 7th would be 20m to the 8th. 10m times this would be this. 10m times this would be this. So you can always multiply to check your work. Okay. Let's look at number 23, some big numbers here. So we've got 18, 60, and 54. What do they have in common? Is 2 a factor of all of those? Yeah, they're all even, so 2 would be a factor. Does 3 a factor of all of those? It actually is. Does 4 go into all those numbers? No. Does 5? No. Does 6? Yes, 6 is a factor. If 2 and 3 are a factor, 6 is always a factor. So let's see how that goes. Let's factor out a 6. So this would be 6 times 3, 6 times 10, 6 times 9. Here's how you can check if you got the greatest common factor. The second factor that's left, these guys have nothing in common. So we've got a 6 out in front. They all have n's. The lowest power is n to the 4th. So we took out the factor of 6. So we have 3 times 6n to the 4th times 3 would be 18n to the 4th. Common factor of 6 is out in front. We have n to the 4th out in front, so we just need an n to the 1st left here. And then we took out a factor of 6, so this will be a 9. And this is n to the 4th. We need n to the 10th, so we need n to the 6th. Okay? Enough on this. Good luck on your practice. Let me know if you have any problems. Bye.